Hey guys, in this playlist and in this video, we are going to be simplifying trigonometric or trig expressions. And the first one we're going to look at right now is on the screen. We have tangent squared theta over secant theta plus 1 as a fraction plus 1. And what we want to do with this is simplify. So I decided to actually do this a little differently than I usually do. And I'm sort of making these into flashcards because I think it would be kind of good to put them in a little stack together and shuffle them up and maybe even rank them easy, medium, hard, and just have a bunch of examples ready to go, you know? So I wrote the original problem big on the front, and then I wrote it a little smaller on the back so that there's some room to do work. I also prepped a couple other flashcards to help us with some of the fundamental identities, such as the reciprocal identities, quotient identities, Pythagorean identities, and manipulating them in ways that are crucial to our ability to do something like this. So let's get started. When I look at an example like this, and I've spoken about this in class and probably in other videos recorded in the past, when my denominator has a sum or a difference, I tend to go the multiply by the conjugate approach. However, I'm going to switch this one up just a smidge, but you can still do multiply the top and the bottom by secant theta minus 1. I'll give you a little hint how it should work out. When you multiply, you won't distribute the tangent squared theta to the secant theta minus 1 on top. You'll just leave them next to each other, secant theta minus 1 parentheses. However, on bottom, with its conjugate, secant theta plus 1 and secant theta minus 1, you will distribute or multiply. And because they're conjugates, when you multiply them, you get the difference of two squares. And that will be secant squared theta minus 1, which is actually a manipulated or modified version of one of the Pythagorean identities. And things will simplify quite nicely. So we're going to sort of see that in a reverse way, where I'm going to start with the tangent squared theta, change it into a difference of squares, factor it, and reduce. So let's go ahead and get started. So here is the example that we are working on. Now, a couple things. Like I said, I prepped ahead of time. If you had a flashcard for yourself, divide sine squared theta plus cosine squared theta equals 1 by cosine squared theta on both sides. What would that turn into? What is sine squared theta divided by cosine squared theta? You should know the answer to that. It's one of the quotient identities. Then what is cosine squared theta divided by cosine squared theta? And what is 1 also divided by cosine squared theta? Obviously here, anything divided by itself, you should know equals 1. And 1 over cosine squared theta, you should be able to figure out using the reciprocal identities. Here I worked it out, and that would give us one of our three classic Pythagorean identities. Tangent squared theta plus 1 equals secant squared theta. So hopefully this is something we are all pretty good at figuring out, or that we know by heart and have memorized. I think it's more beneficial that you know how to figure it out than it is to straight up memorize it, but let's go for 50-50, right? So now that that's done, here's another card I made for a study set here. Given tan squared theta plus 1 equals secant squared theta, which is our Pythagorean identity, isolate tan squared theta, then factor. So what would that look like? How do you isolate tan squared theta? Well, you subtract 1 from both sides. That would give you secant squared theta minus 1. Again, like I mentioned earlier, that's the difference of two squares. We factor using conjugates. So we would have secant theta plus 1 and secant theta minus 1. And this is what that looks like. Here I subtracted 1 to the other side. So I got that right there. And then I factored using conjugates. Now, let's apply what we just reviewed to this example. The first thing I'm going to do is I'm going to replace tan squared theta with secant squared theta minus 1, still over secant theta plus 1. It's important you remember that you cannot reduce pieces of sums or differences from a numerator and denominator. You have to reduce a factor or something being multiplied. So that would not work out for us. From here, I'm not using equal signs. If I were to go horizontal, I would use arrows. I'm going down because I'm simplifying, okay? I'm going to factor this numerator right now. Again, difference of squares. It doesn't matter which parenthesis you put first or which factor you put first. There's my new numerator, my factored numerator, over secant theta +1. Now, every numerator or denominator is allowed to have implied parentheses around it. So if you'd like to draw them, if that helps you get a better visual, you could do that. Don't lose the +1. That's a common type of mistake. It's going to scooch around now with an arrow. Now that we have these factors in our numerator and denominator, we can simplify. Secant theta +1 and secant theta +1 reduces, right? I'm just going to make this plus sign a little bit more clear, so when we use this to check or study, we could see a little better. Those reduce, and we're left with the secant theta -1. Now, you don't need these parentheses around it anymore, +1. I'm going to write it for a step, but I hope we all understand that they are not necessary. And then -1 +1, that is what we call canceling, turns to 0. And final answer is secant theta. So that entire expression on the other side of the card simplifies to just secant theta. So hopefully you understood that. And if you wanted to try what I described earlier, give it a try, press pause, whatever. And I'm going to try to be linking another example video at the end of this video. So hopefully it just brings you through the playlist. It'll pop up on the screen or a link to the playlist. And hopefully the thumbnails are all pictures of the example so you can kind of pick and choose what example you'd like to see. Okay? Hope this was helpful. Have a good rest of your day.